This is Facility Science Podcast number 13. I am Jason Doolittle, and today I'm talking about BACnet. And just get right into it. BACnet is a data communication protocol for building automation and control networks. BACnet is BAC for building automation and control, and then net for network. So BACnet, building automation and control network. BACnet defines standard methods of communication and also data representation that allow building automation and control devices from different manufacturers to communicate with each other. Basically, this means that if a manufacturer develops their device communications and a data representation to the BACnet specification, their device will be able to communicate with any other device that implements the spec, no matter the manufacturer. And prior to something like BACnet, you would often be locked into either a certain manufacturer's proprietary technology or to a very simple communication using, say, relays and things like that, or to sort of expensive, customized integration if you wanted your devices to communicate with each other. And, these days we have very powerful computerized integration platforms that allow communication among devices using different standards and technologies, but we still need non-proprietary standards like BACnet, and there are lots of others, for those integration platforms to be able to do their integrating thing. And here's a quote from BACnet website, that's bacnet.org. Developed under the auspices of the American Society of Heating, Refrigeration, and Air Conditioning Engineers, that's ASHRAE, BACnet is an American national standard, a European standard, a national standard in more than 30 countries, and an ISO global standard. And that's the end of the quote. And BACnet has been under development since June of 1987, and the first standard was published in 1995 as ANSI ASHRAE Standard 135. And in 2003, BACnet became an ISO standard, that's ISO 16484-5. So what does BACnet actually do or allow us to do? We want to connect our building systems together in some kind of network that allows them to communicate with each other and allows us to communicate with them in order to integrate automation and control of the various building systems. And in order to create this network, or any network really, we need to know physically how to connect the devices together. So what kind of wires or radio waves or whatever we need to use to do that. We also need to know what kind of electrical signals or radio waves represent data. And generally when we're talking about data here, we're talking about bits, so it's zeros and ones. So we need to know, say, which electrical signal represents a 0 and which represents a 1, and maybe how to detect and correct errors and that sort of thing. And then we need all of the devices that we're going to put on this network to be able to do these things in the same way. And then in order to actually communicate with the devices across this network that we're putting together, we need to know how to do things like ask the device for its name or for the values detected by its sensors. We need to know what kind of data we need to send to the device in order to get it to do something. And we also want to know the format of the data the device will send back to us when we query its values or tell it to do something. And again, we need all of the devices on the network to do these things in the same way. So BACnet defines what we call a stack of protocols. And I talked about the concept of protocol stacks and layered abstraction in number 1 of this podcast, which was about how the internet works. And the idea is basically that we can define, for example, a physical layer, which is how to physically connect things, like I talked about before. And then we can define another layer, which, for example, might identify different devices on the network that doesn't depend on the details of the physical layer. And if we define those layers correctly, we can swap out the layers for different supported layers without affecting the other layer. For example, we can use a wireless layer that transmits data with radio signals rather than a wired layer that sends electrical signals along cables, while using the same mechanism to identify the devices if we sort of set it up to support that. So BACnet doesn't actually define the mechanisms to physically connect the devices. The designers of BACnet recognized that this problem had already been solved, so they instead designed the upper layers of the BACnet stack to use existing methods, and then they just tell us which of those existing methods to use. In modern control networks, there are 2 main flavors of connection technology we use to connect the networks together. There are a few others, but there are 2 main ones that if you're going to put a BACnet network together now, you would use one of these 2 and possibly even both in combination. And these are known as BACnet MSTP and BACnet IP. So BACnet MSTP is designed to be used over EIA 485, which you might know as RS 485. And this is a two-wire serial communication standard that's pretty old, but it's still very useful and it's extremely common. And EIA 485 allows us to connect multiple devices together by connecting one device to the next in a chain topology. So rather than invent something new, the BACnet people just said, use this, EIA 485, we already know how it works. That's not an actual quote. The BACnet then defines a protocol called MSTP, that's master-slave token passing. That's sort of a description of how it works. That specifies how the device will pass BACnet messages across the EIA 485 wire. And as far as I know, which isn't that far to be honest, I don't think they define any physical layers other than EIA 485 for MSTP. It's conceivable that the BACnet group could define other physical layers with a connection topology similar to the EIA 485 and then make MSTP work over that. I think EIA 485 works well enough though, and everyone knows how to use it, so there's no real need for that. Now, BACnet IP is designed to be used over the kind of networks we use to connect computers in our offices and across the internet. So the IP stands for Internet Protocol. And again, if you want more about this, you can refer to number 1 of this podcast called How the Internet Works. And I should probably also point out that BACnet IP actually uses UDP, that's User Datagram Protocol over IP. And UDP is one layer up the Internet Protocol stack from IP. And again, see number 1 of this podcast if you want the details of all that. And by relying on IP, Internet Protocol, BACnet can communicate across any of the lower layer network types supported by IP. The most common of these is Ethernet, but you could use any one because we're relying on IP, and everything under IP we can use. And Ethernet is something you're probably familiar with, at least casually, if you work in a modern office or even have a home and connect to the internet. And by the way, BACnet can also be used across Ethernet without using IP, but then you lose the functionality provided by IP that allows you to route message across different networks. And again, I'm trying not to get too deep into that here. See episode number 1 of this podcast for more about that. A term you might hear related to BACnet IP is BBMD, that's BACnet Broadcast Management Device. And BACnet gains a lot of benefits by relying on Internet Protocol, on IP. But there was a conflict between functionality required by BACnet and functionality provided by IP. BACnet requires the ability to send messages to all of the devices on the network at once. And we call this a broadcast or a multicast message. And IP just so happens to provide such a mechanism. The problem is that IP doesn't allow broadcasts to cross network boundaries. And this makes sense because if IP allowed broadcasts across network boundaries, every broadcast message on every home or office network would reach every device connected to the internet, and the internet would be flooded with these things, and that wouldn't really work for anybody. So imagine you have your main office and also a remote site, and you have a BACnet network at both sites, and you want to connect both networks together so that you can manage them as one. And this kind of thing is exactly what IP was designed for, and it works perfectly for that, except for the broadcast problem. The individual devices in your BACnet IP network can communicate with each other just fine from one network to the other using IP, because that's what IP does. But if you send an IP broadcast from inside, say, the home office network, that's supposed to reach every BACnet device on the BACnet network, the message will never reach the devices at the remote site because those IP broadcasts won't route across the internet. So enter the BBMD. The BBMD concept was devised as basically a broadcast relay. So you would have a BBMD at each site, and they would know how to reach each other. And the BBMD's job is to listen inside its network for BACnet broadcasts and then forward them to any other BBMD it knows about. And then if a BBMD receives a broadcast from another BBMD, it relays the broadcast into its network. So problem solved. And if you want to know some more details about BACnet IP and its development, there's a pretty thorough tutorial over at the BACnet website, and there's a link to that in the notes for this episode. Another thing we use when we're putting together our BACnet network is gateways. Sometimes we want to connect a non-BACnet device to our BACnet network. And for this, we use what are called gateways. And the gateway is a device that speaks both BACnet and whatever is used by the non-BACnet device. And this would have to be a device specially made to communicate between those two different technologies. And the gateway maps properties of non-BACnet devices into the BACnet object model, and also deals with communicating the BACnet way over IP or over MSTP on the serial network. So creating networks of devices and deciding how to communicate data with electrical signals and routing stuff among networks is a problem that has been effectively solved for general use. So the real benefit of BACnet then is for the specific case of how to organize and communicate data in the context of automating and controlling our building systems. BACnet allows the creation of a standardized, abstract representation of a real device. Right? So BACnet specifies an object model to represent the characteristics of our building system devices. So each device is represented as a BACnet object. And this will be immediately understandable if you've ever done any object-oriented programming, but maybe not if you haven't. But an object in this context is simply a list of named properties. And a BACnet device is defined by a set of objects. And so the device itself is represented as an object. And again, as object is just a list of properties. And some of those properties could be other objects. So objects represent things like physical inputs and outputs. So if your device has a sensor on it, your object model of the device would have an object that represents the value of that sensor. So each object is a collection of properties that can be used to get information about the device or to change the state of the device. So examples of some properties that an object might have would be the name of the object. Another one would be the type of the object. So is it a binary input or a binary output, or is it an analog value? Maybe the units of measurement of whatever the value is, some type of status flag. And so these are examples of object properties. And the properties in an object might be read-only, such as the value detected by a sensor. So you couldn't necessarily tell the device what that value is. It's going to tell you. You can't change it. It's just based on whatever the sensor says. Or they might also be writable, such as a set point or a control point of some kind to turn something on or off. That's something that you'll want to tell the device what the value of that should be, or maybe some schedule will tell it or whatever. And BACnet defines a number of standard object types. Each object has to have a type. BACnet defines a number of standard types, and there are 20-something, 23 or 25, I'm not sure exactly. And examples of these are, the binary input, the analog output, a trend log, a command, etc. There's, like I said, there's 20-something of them that are standard in the spec. And so an example of this would be a thermostat. So a BACnet thermostat might present the following objects. It might present the space temperature, right? So this object represents the temperature detected by the sensor in the thermostat. So it would have an object name of space temp or something like that, an object type of analog input, a present value it'll have, might be 27 degrees, and it might also have a calibration value. So the object name and the type and the value might be read-only. You can't change them. They're going to tell you what they are. But say the calibration value might be writable. You're going to tell it what its calibration value is. Okay, so using this object model, BACnet defines a set of what they call interoperability areas. These interoperability areas are the kind of things that we want our building automation and control devices to do. And these areas are data sharing, so that's for control and monitoring. But we're going to be able to get information from the device and tell the device information. Scheduling, which is just what it sounds like. It's get the device to do something on a schedule. Trending is we want to get a time series of values to see what's happening over time. Alarm and event management, and also device and network configuration and management. Those are our 5 interoperability areas. And we use what are called BACnet interoperability building blocks, BIBBS, so BIBs, BACnet interoperability building blocks, as a standard way to represent device capabilities. And these are useful when making specifications for a system or for a device, and also when comparing device capabilities. So there are BIBs for each of the interoperability areas. And some examples of these are, for data sharing, we have the BIB, and the way these are formatted is DS-RP-A, and DS-RP-B. So the DS in this case stands for data sharing, so that's the interoperability area. The RP in this case stands for read property, and the A stands for whether this is the client or the server. So if a device has a bib of DS-RP-A, that means it has the data sharing capability read property, and the A means it has the capability to request a read of another device's property. And then the DS-RP-B, the B represents that the device has a value to read and will give it when a device asks for it. Right, and then, so another interoperability area we have is the trending interoperability area. And so example of a bib in that area is T-V-A. So the T for trending, the interoperability area, the V is for viewing, and the A is, again, A and the B are the client or the server. So a device with a TVA bib is a device that will ask another device to view its trend, and a device with a TVB bib is a device that will give the data of a trend to a device that asks for it. And then just one more example of a bib is in network and device management interoperability area. You might have one called DM-TS-A and DM-TS-B. So device management is the DM. TS would be for local time synchronization, and then the A and B, same as before. So this would be a device that knows how to synchronize its local time with another device. All right, now we get into what are called device profiles. A device conforms to one or more device profiles. The categories for these profiles are operator interface, controller, miscellaneous, and general. An operator interface device profile is what it sounds like. It's the device that a person who wants to interact with the network would use. So the workstation or a display, and there's several categories of workstations and displays. The controller profile would be a device that does things in the network, and there's various levels of that also, from varying levels of programmability. And some examples of the various levels would be, so you would have one called a B-AAC. AAC stands for Advanced Application Controller, and then a BASC. So that's application specific controller. So the difference between these two is that the AAC, the advanced application controller, might be more programmable. It's something that would be used for more general purpose control, whereas an application specific controller would be less programmable. It'd be something that would be built into, say, an air handler. The air handler has a specific programmed function that it does, and the application specific controller just knows how to do that one function. Then you can go down even to a simpler device, a B-SA, that's a smart actuator, and a B-SS, a smart sensor. A smart actuator is just a device that if you give it the command, it'll do whatever its physical task is. And a smart sensor, just what it sounds like, it'll get a value from the environment, and you can ask it for its value. So those are examples of devices in a controller profile. You also have the miscellaneous profile, and those are devices for connecting networks. That's the routers and gateways and BBMDs, which we talked about before. And then the general category is devices that don't conform to the other profiles. And a device can conform to multiple profiles with some limitations. I think the most notable limitation is that it's not going to conform to multiple profiles in the same profile category. The way the profiles are specified is by using the BIBs that we talked about before, the BACnet interoperability building blocks. So for each profile, there's a required set of BIBs. And in order to be classified as a device of that profile, a device must have all of the required BIBs. And then there's another sort of related to this device profiles and the BIBs is for each device, you'll get what's called a protocol implementation conformance statement, PICS. And that tells you the BIBs supported by the device, the network type supported, and the profiles the device conforms to. And these things are put together by the device manufacturer to tell the specifier or the designer or the integrator what the capabilities of a particular device are. There's much more to say about BACnet. There's security, which is big and important and developing as well. There's also how BACnet relates to the IoT, the Internet of Things, and there's other things. And I hope to cover these in the future. But before I wrap this up, I do want to say a couple of things about BACnet security. The first one is that there are some developing and also developed standards in the BACnet spec related to security, which might be very useful in the future. Two examples of these are the BACnet WS, that's BACnet Web Services, which tackles some security issues. There's also BACnet SC, BACnet Secure Connect. SC is for Secure Connect. These are not widely deployed or widely tested, and I wouldn't recommend relying on them in the present. Right now, the present means mid-2019. So for BACnet IP security, it's important to have a good security for your IT network. Please don't expose your BACnet network directly to the internet. This is unfortunately much more common than it should be. Instead, you want to use a VPN and tunnel through that if you need to connect multiple sites across the internet. And that's my opinion. Consult your relevant experts and all that. There's also physical security. So anyone with physical access to the devices or cables can gain access to your BACnet network and mess with your building systems, and that's not a good thing. So it's important to secure those as well. It's not just what someone can do over the network. It's also what someone can do if they actually have access to your devices. And that could be something as simple as the cable running outside the building to the generator enclosure. If that's exposed, someone could potentially tap into that and have access to your whole BACnet network. Again, security is a whole topic by itself, so I don't want to get too deep into that here. Maybe I'll cover that later. And that's really about all I want to say about BACnet for now. If you have any questions or comments about this topic or any suggestions for topics you would like to hear about, you can contact me by email at podcast@facilityscience.com. You can also contact me at Facility Science on Twitter. If you like this podcast, you think it's useful, and you want to help me make more, you can go to facilityscience.com/support and see if any of the options there appeal to you. And I hope this was useful to you, and thanks for listening.